Good day! Yung lesson natin ngayon ay laws on logarithms. We first encountered logarithms as the inverse function to the exponential function. Could also look at it as the inverse operation of exponentiation. At the same time, yung logarithms na operation, madami siyang properties na pwede nating i-explore that will give rise to these laws on logarithms. And interesting kung saan siya kukunin, based lang dun sa basic definition natin of what the logarithm is. So let's proceed. So ano yung gusto nating matutunan ngayon? We'll explain and apply the laws on logarithms, specifically itong apat, yung product rule, quotient rule, power rule, and the change of base of logarithms. Then we'll use these laws of logarithms first to play around with logarithmic expressions by expanding and condensing. Siguro sa video na to, hindi muna ako aabot dun sa exercises. Ilalagay ko na lang siya sa separate video. So this will just be a lecture video on the concepts. Then we'll have a second video for the actual exercises and examples. I hope that's okay. Before we proceed sa first law natin on logarithms, balikan lang natin mabilis itong product rule of exponents. So if we have a base na positive, that's not equal to 1, yung b raised to m multiplied to b raised to n equal siya sa b raised to n plus n. So this should be something, no, na as early as grade 7, aware na tayo. To extract the product law of logarithms, I will construct a variable capital M and let it be equal to b raised to m, yung unang factor natin. I'll also need a second variable capital N, which is equal to b raised to lowercase n, yung second factor natin. So yung left-hand side ng original equation natin na b raised to m times b raised to n, that will be equal to capital M times capital N. And as we know, when we multiply b raised to m to b raised to n, equal siya sa b raised to m plus n. Now this expression, capital M equals b raised to lowercase m, following yung definition natin ng logarithms, pwede natin siyang isulat na lowercase m is equal to log base b of capital M. We can do the same for the second variable, capital N, na lowercase n is equal to log base b of capital N. This is just our definition of logarithms. Ngayon, itong third equation, pwede natin siyang isulat na exponent na m plus n that is equal to the logarithm base b of capital M times capital N. So I hope up to this point nakakasunod tayo. Ang left-hand side natin dito ay M plus N. Ito si M. Ito si N. So substituting log base B of capital M here and log base B of capital N dito sa lowercase n, we'll have this equation na ang log base B ng capital M times capital N equal siya sa log base B of capital M plus log base b of capital N. Anong sinasabi nito? If we take the logarithm base b of a number, equal siya sa sum ng logarithm ng factors niya. Again, ang logarithm ng isang number ay equal sa sum ng logarithms ng factors niya. Kung bakit to important, I hope I can make it clear later. But that is very important. That's a very important concept. I will be collecting yung ating laws of logarithms for this session sa slide na to. Product rule, we have a quotient rule. And we'll start with the quotient rule of exponents first. Tandaan natin to. That if we have b raised to m divided by b raised to n, same base, we subtract the exponents. This is equal to b raised to m minus n. Let's do the thing na ginawa natin kanina. Let capital M be equal to b raised to m and capital N be equal to b raised to n. The quotient of b raised to m over b raised to n is equal to capital M divided by capital N. Kasi yun yung quotient na gusto natin eh. But this is established, so yung quotient nila is b raised to m minus n. Again, sa definition natin ng logarithm, yung first variable natin, si capital M, pwede nating isulat na lowercase m equal to the logarithm base b of capital M. Ganun din kay capital N. na si lowercase n ay equal sa logarithm base b of capital N. And the third equation, we can write this as m minus n equal to the logarithm base b of capital M over capital N. Combining these three equations sa kanan, we have logarithm base b of capital M divided by n equal siya sa difference ng logarithm ng numerator minus the logarithm of the denominator. So to summarize this rule, the logarithm of a fraction is equal to the logarithm of the numerator minus the logarithm of the denominator. And this is the quotient rule of logarithms. Sama natin dun sa slide na kinokollect natin yung rules. Again, yung restrictions ng base will apply. So mabilis, yung product rule, the logarithm of a number is the sum of the logarithm of its factors. The logarithm of a fraction is the logarithm of the numerator minus the logarithm of the denominator. Now, puntahan natin yung isang corollary or repercussion ng quotient rule. Now, if you are taking the logarithm, base b, of a 1 over something na fraction. So, the logarithm of 1 over something, applying the quotient rule, this is the logarithm of the numerator, which is 1, minus the logarithm of the denominator, which is n. But, ano ba ang logarithm ng 1? Kahit anong base. Again, ano ulit to? Ano yung number na pag niraise ko si base, I will get 1. So, the logarithm of 1 for any valid base is 0. So, yung logarithm base b of 1 over n, this is 0 minus log base b of capital N, which is just negative log base b of n. So, yung corollary niya, if you're taking the logarithm of 1 over something, that's just the negative of the logarithm of the something. And this is an application of the quotient rule. So before we proceed with the other laws of logarithms, I just want to take a quick look at the history of logarithms at kung bakit siya very, very important nung time na na-develop siya at na-discover ni John Napier. So siya yung credited for having discovered and formulated the laws of logarithms. So this was around the 17th century, mga 1640 something. And you have people like astronomers who are trying to compute and plot yung courses ng mga planets and ng mga stars. And they have to do a lot of trigonometry and a lot of computations. Now, take note, this was in the West. Wala silang access to an abacus. So, yung mga techniques sa abacus ng pag-multiply, maybe they don't have access to that. And they have to multiply lots and lots of numbers na madaming significant digits or madaming decimal places. And multiplying several numbers just to get one value, that could be very, very time-consuming. Tapos mahirap ding hanapin kung saan nagkamali. And we have to agree, no, that addition, kahit madami kang addends na i-add, it's an easier or a less complex operation than multiplication. So, what the discovery of logarithms essentially did was it made the computational tasks of multiplying numbers easier by reducing them to addition. So, imbes na nagmo-multiply sila ng large numbers, nag-a-add na lang sila ng large numbers pa din, but it's computationally less complex than actually multiplying them. So, paano nila yun ginawa? After having discovered the laws of logarithms, yung first major task was computing the logarithms of numbers. And all they had to do was compute the logarithms of numbers from 1 to 10. And here is a sample table of logarithms na mas modern. In this modern table of logarithms, computed na yung logarithms ng 1.00 hanggang 9.99. So how this works is, ito yung first two digits, ito yung third digit, tapos ito yung mga logarithms nung numbers na binubuo nung tatlong digits na to. So for example, the logarithm of 3.44 is 0.537. Now, of course, yung pag-compute ng logarithms nito, mahirap at mas mahirap siya sa pag-multiply. But what they had to do was upuan lang siya ng matagal na panahon, i-compute lahat tong logarithms na to, isulat siya sa isang libro, at i-recopy na lang yung libro na yon. So in a sense, the hard work is being uploaded in front, gagawin na siya ng certain specialists. Pag na-compile na nila tong tables na to, ibibenta na lang nila sa mga mathematicians, sa mga engineers, sa mga astronomers who need to use these tables for computation. And the actual tables they used had more decimal places than these ones that we will be using. So basically, pang demo lang to. Yung talagang logarithm tables that they had to use, it contained more pages, more information, more decimal places. But essentially, they're taking the logarithms of numbers from 1 to 10. Pero dahil more decimal places, mas madaming pages silang kailangan. So, pang demo lang to, and this will not be very accurate for our lesson. So, how does this make computation easier for the people who actually need to do the computations? Again, mahirap mag-compute ng logarithms, pero ginawa lang siya ng isang team siguro or a bunch of people, and they only had to do it once. Once na-compute na nila yung table of logarithms, hindi na nila kailangang ulitin yung effort na yon. So how does this work? For example, I want to multiply 3,740 by 89.3. How this would go if I were to compute this using a table of logarithms and without a calculator? Well, I will do this step by step. Pero syempre, kung gamay na natin yung logarithmic tables, you can skip a lot of the steps here. But what would you do mentally first is to write each factor as a logarithm. So instead of 3,740 and 89.3, we'll write logarithm of 3,740 at logarithm of 89.3. Tapos, check natin yung logarithm ng 3,740 dun sa table natin, tsaka ng log ng 89.3. Pero teka, sabi natin yung table natin, 1 to 10 lang yung kinompute nating logarithms. Well, tandaan natin na ang 3,740 ay 1,000 times 3.74. Ang 89.3 ay 10 times 8.93. Using the product rule of logarithms, we could separate this into sums. Na instead of logarithm of 1,000 times 3.74, it's logarithm of 1,000 plus logarithm of 3.74. Same here. Note that I'm using base 10, no? Kaya wala akong naka-specify na base. Pero ano ba ang logarithm ng 1,000? Remember, this is base 10. And the logarithm is, ano yung number na pag niraise ko yung base ko, makukuha ko yung 1,000. So that's 3. Dito naman, ano yung number na pag niraise ko si 10, makukuha ko 10. E di syempre 1. So we know the logarithms of 1,000 and 10 respectively. Ito yung di natin alam. Logarithm ng 3.74 at logarithm ng 8.93. So, dyan papasok yung table. First, I will look up the value of log of 3.74. 3.74, ang logarithm niya ay 0.573. Note that this is just an approximate value. Madaming decimal places to. So, yung sagot din natin makukuha, it will not be an exact value, but just a close approximation. So, we write this as 3 plus 0.573. Kasi ang log nga ng 1,000 ay 3, then from the table, ang logarithm ng 3.74 ay 0.573. So this is equal to 1, and we just have to look up yung value ng logarithm ng 8.93. So 8.93, the logarithm is 0.951. So 8.93, the logarithm is 0.951 for base 10. So we'll have an approximation of 1 plus 0.951. So this is approximately 3.573. This is approximately 1.951. Bakit approximate? Kasi this would have more decimal places pa pagkatapos. Now, following yung product rule of logarithms, the logarithm of this product will be the sum of these two logarithms. So that's the first rule, di ba? The logarithm of a number is equal to the sum of the logarithms of its factors. At ito yung logarithms ng factors niya. And the sum is approximately 5.524. Well, equal na siya dyan. Pero kasi approximation lang tong dalawang to eh. Now, 5.524. Pwede nating biyakin sa 5 plus 0.524. And yung 5, logarithm yan ng something, at yung 0.524, logarithm din yan ng something. So, si 5 ay logarithm ng ano? So, log of what? Base 10 will give us 5. By the definition of logarithms, yung 5, that will be log base 10 of 10 to the 5th power, or 10,000. So, alam na natin na this is log of 10,000. Check na lang natin sa table natin kung log ng ano si 0.524. So, from my table, 0.524 is the logarithm of 3.34. Again, 3.34. So, this is the log of 10,000 plus the logarithm of 3.34. Again, by the product rule, the logarithm of 10,000 plus the logarithm of 3.34 will be equal to the logarithm of the product of 10,000 and 3.34, or the logarithm of 334,000. So, log ng 3740 times 89.3 ay approximately log ng 334,000. So, ang product na 3740 times 89.3, that is approximately 334,000. And the actual correct value is 333,982. Okay na siya na approximation. I'm only off by 18 sa isang number na 6 digits. Na mukha siya mahaba, no? Kasi biniyak natin isa-isa eh. But to the astronomers nung 17th century, syempre hindi na nila yan bibiyakin ng ganyan. Matik na nila makita, 1,000 to. So that would be 3. Tapos kukunin na lang nila yung first digits. Those steps can be shortened. And what they are doing is they are doing addition instead of having to do multiplication. They are choosing to do an easier operation, at ang kailangan lang nilang gawin ay bilhin yung book na table of logarithms. So it's a big mathematical discovery, and it's also a way to earn money. So parang nagbebenta ng computer, except that your computer is in the form of some printed matter. It's a good thing that this corresponded, no, na meron na silang access sa printing presses at hindi na nila kailangang isulat by hand. Let's do another example of using the logarithmic tables, but this time sa division naman. And we'll try to skip a lot of the steps na ginawa natin kanina. So before we proceed, ano yung gusto natin gawin? Gagamitin natin yung quotient rule ng logarithms na the logarithm of this fraction, 737 over 23.9, is equal to the logarithm of 737 minus the logarithm of 23.9. So, kung ano man yung nasa loob ng logarithm na yun, yun yung quotient nila. So, let's try to do it. I will look up 737 sa logarithmic table ko. I don't have 737. Ang meron ako 7.37. And that is 0.867. And I observe that this is hundreds, in the hundreds. So, meron akong 100 times 7.37. I don't need to write that down. Sulat ko na lang siya na 2.867. Again, 0.867 yung logarithm ng 7.37. Saan galing yung 2? Kasi may times 100 pa tayo. So, kita ko 737. 2. Look up the table, 867. Divided by. Pero ito na yung logarithm, no? So, magiging subtraction na to. The logarithm of 23.9. Dahil this is 10 times 2.39, alam ko ng 1 point something to. So, look ko na lang yung something. 2.39. 0.378. So, dahil times 10 siya, 1.378 yung logarithm niya. So, minus 1.378. Then, I do my subtraction and I get 1.489. Then, I will go back to my table. At dahil 1, yung first digit, alam ko na hanggang 10th digit lang ako. And now, I will look up 0.489 in my table. So, 0.489. So, reverse lookup siya. Dito na ako titingin. Arrange naman to in increasing order, left to right, pababa. So, 0.489, that is the logarithm of 3.08 times 10. Kasi may 1 dito, I get 30.8. As the quotient of 737 and 23.9. Now, ano yung totoong quotient? It's 30.836. It's not exact. Kasi kulang ng decimal places yung log table ko, but it's good enough for an approximation. So, ganito lang kabilis yung gagawin nila. I mean, for multiplication, maaaring mas mabilis natin siya magawa. But for division, it's the same amount of effort. Look up, subtract. For multiplication, look up and add and look up again. Regardless kung ilang number of digits. Ang challenge mo na lang ay gawin ng tama yung addition and subtraction. So there is less room for mistakes and there is less increase in complexity pag dumadami yung digits na kailangang i-multiply or divide. Okay, so I hope meron tayong konting appreciation kung bakit very, very useful yung konsepto ng logarithms noong 17th century. Admittedly, at around our time, may calculators sa tayo at maybe hindi na ganun ka big a deal mag-multiply ng large numbers or numbers na maraming places. But syempre, logarithms will always have its place in our hearts. Third rule, the power rule for logarithms. So, tatry natin siyang i-develop. And to develop that, I'll start by assigning capital M to be equal to b raised to y. And we can write this as a logarithm na y is equal to log base b of m. So, ito yung definition natin ng logarithms. My next step is, i-raise ko ngayon si capital M sa some constant k. Siyempre, kung ni-raise ko si m sa k, that is equivalent to raising b raised to y to k. And by the laws of exponents, yung b raised to y raised to k is equal to b raised to y times k. Apply natin yung definition natin ng logarithms dito. So, m raised to k is equal to b raised to yk. That is equivalent to logarithm base b of m raised to k equal dun sa yk, or in this case, ky. Pero, ano ba si y? Y is log base b of m. Ito siya. So, this is now our power rule for logarithms. Mukhang ang bilis, pero ito na talaga yon. At ang sinasabi lang niya ay, if you want to find the logarithm of a number raised to a power, yung k na yon, pwede mong ilipat sa harap at gawing product. So, basic example, logarithm base b of x squared. Ang logarithm base b of x squared equal siya sa logarithm base b of x plus logarithm base b of x. So, 2 times logarithm base b of x. But in this case, ginawa natin for a more general case. Kahit hindi integer si k, this rule will apply. So, again, if you're taking the logarithm of a number being raised to a power, yung power, pwede mo siyang ilipat sa harap at gawing multiplier or coefficient. So, adding it to our list of rules, the product rule, the quotient rule, and the power rule. Let's go to our fourth rule, yung change of base formula. Start tayo dito. Let my y be equal to log base b of capital M. Now, syempre, by the laws of logarithms, pwede natin siyang isulat na b raised to y is equal to capital M. Now, we know that the logarithm is a one-to-one function. Kasi inverse siya ng exponential function, which is also a one-to-one function. So, dahil one-to-one function siya, we could use that to take the logarithm of both sides of an equation. So, I will take the logarithm of the left-hand side and the logarithm of the right-hand side, and it will still be equal. We have this expression now. Note that I am using another base A. So, it's a different base from base B. So, logarithm base A of b to the y equals just the logarithm base A of m, which we got by taking the logarithm of both sides nitong equation na to. We will now apply the power rule for logarithms for the left-hand side and we'll transfer yung y sa harap para maging coefficient. So we have y times log base A of b is equal to log base A of m. Now, log base A of b is just a number kasi b is just a number and log base A is just a number. And I can divide both sides by log base A of b to arrive at this expression. Y is equal to log base A of m divided by log base A of b. Pero ano ba yung y natin? Yung y natin ay log base b of m. So, we have arrived where we want to arrive. The change of base formula, which says that the log base b of m, pwede ko siyang isulat na log base A of m over log base A of b. Or, baka mas madali kung baliktarin natin yung intindi, kailangan ko gumamit ng log of a certain base. Pero meron lang ako base A. Paano ko pupunta from base A to base B? Well, ang gagawin ko ay log base A of M, di-divide ko siya ng log base A of B, kung ano man yon. At maisusulat ko na yung logarithm ko using another base, which is why this is a change of base formula. Now, swerte tayo, no, na at this point, hindi natin masyadong problema mag-compute ng logarithm ng kahit anong base. Because our calculators, pag ginamit na yung mga cycle natin, pag in-attempt natin mag-take na logarithms, tatanungin niya tayo kung anong base yung gusto natin gamitin. That was not the case nung high school ako. So this is a calculator from the 80s. Hindi ako high school ng 80s. High school ako 1993. So we had a bit more nicer calculators than this one. Pero by nicer, ibig sabihin lang, nakikita ko yung exponent. Pero yung keys, ganito pa rin. And you will observe, no, na yung logarithm keys sa lumang calculators, naka-default lang sila sa log base 10, tsaka sa ln, yung log base e. Hindi mo pwedeng specify ang base 2 or base 5 o kahit anong base na gusto mong gamitin. Stuck tayo dito sa dalawang bases na to. At okay lang yun. Kasi pwede ka namang gumamit ng change of base formula para kung ang kailangan mo ay base 3 at hindi base 10, nagagamit mo pa rin si base 10 na logarithm. But again, that's not such a big deal right now sa atin kasi our calculators have been developed to the point that you can specify the base. But this is an interesting consequence. By playing around with the concepts of logarithms, makukuha natin tong result na ito. So this is one of those things, no, that would have made computation so much easier if you're in the 17th century. Buti na lang, wala na tayo 17th century in terms of technology. Ewan ko in terms of thinking and mindset and philosophy. But at least, in terms of computational technology, wala na tayo doon. And we don't have to remember all these laws na lang. And they just become interesting things that we encounter sa mathematics. So this is a very historied concept which is happily not very much needed sa panahon natin ngayon. So we're here to appreciate it and look at instead other applications ng logarithms kasi meron pa. Pero at least in terms of making computation easy, not so much na anymore. So let me summarize the 4 rules of logarithms that we covered in this session. So the product rule of logarithms, the logarithm of a number is equal to the sum of the logarithms of its factors. Quotient rule, the logarithm of a fraction is the logarithm of the numerator minus the logarithm of the denominator. The power rule of logarithms, if you're taking the logarithm of something raised to a power, then yung power pwede mong ilagay sa harap as a coefficient and you're just taking the logarithm of the number. And the change of base formula, if you want to change from base A papuntang base B, you will divide logarithm base A of M by logarithm base A of B para makuha si logarithm base B of M. Siyempre, yung restrictions natin sa base, they will have to hold for all these conditions. Pati si A, it has to follow these conditions. Di ko lang nasulat, but since this is a different base, kailangan niyang positive at kailangan niyang hindi equal to 1. So let's recap kung ano yung mga dinerive natin ngayon. We talked about the product and quotient rules. At pinakita natin, no, na they provide or they have provided a way to find products and quotients using only addition and subtraction. Pinapadali niya yung complexity ng computations. It's not to say tatanggalin niya totally yung difficulty, but at least it becomes less complex. Instead of multiplying and dividing, mag-add and subtract na lang ako. Pero again, syempre, may mga taong nag-effort buuin yung book of logarithms. At mahirap yung process na yon. At di na natin pupuntahan kung paano nila ginawa yon. But the fact is, they only had to do it once, tapos bibenta na lang nila yung results nila. The power rule for logarithms ay na-derive natin from the previous rules, and so is the change of base formula, which we use to shift the basis of logarithms to a more convenient choice, kung meron kayong choice talaga. So hopefully, in our next video, we'll be able to look at several examples na gagamitin natin itong mga laws of logarithms na ito. So, see you sa next video.